I like Joe Scott. Joe brings science in a fun way with simple terms to regular people to understand it.
But as I said, I'm not a scientist, which means from time to time, I'm gonna get stuff wrong. And that's okay.
And that's really okay. We are all humans, we make our mistakes, we have our biases. And that's why we have to use the most scientific resources we can while explaining science to people. However, in his video Busting Climate Change Myths, most of Joe's resources were news websites. So let's go to it.
CO2 is plant food. Yeah, because adding more food only makes you healthier. No, I get the logic. Plants need CO2 to do photosynthesis, so more CO2 would mean more photosynthesis, more energy, bigger plants, right? There's even a term that climate change skeptics have adopted for this. It's called global greening. But go and figure, it's actually a bit more complicated than what you learned in 6th grade science class.
Yeah, then it's time to use the skeptic card on NASA. In their study from August 2019, they say the Earth is greening. 33% of the vegetated area has greened and 5% has browned. Net increase of 2.3% per decade. And they also corrected the previous study. Take a look at how many areas in the world have greened. North America, Brazil, Europe, Central Africa, India, China, and Australia.
It isn't based on CO2 alone. It also needs water and nutrients from the soil. It's that mix that helps it to grow. And if you have higher CO2 without a corresponding uptick in water and nutrients, it doesn't really make a difference. In fact, water is going to be even harder to come by because higher CO2 would mean higher temperatures. Higher temperatures would evaporate more water out of the plant, so it's going to need more water just to maintain the status quo, even more water to be able to make any advantage out of the higher CO2 concentration.
All right. Plants need more water because of higher CO2. These are stomata. They are tiny little pores on leaves and stems of plants. And it's through them that plants absorb CO2 from the atmosphere, but it's through them also that plants lose water through transpiration. The Utrecht University and the Indiana University say that doubling the present CO2 concentration will decrease annual transpiration flux in 50%. This is the before and after. By having more CO2 in the atmosphere, plants need less stomata, and with that, they lose less water through transpiration. And this count of stomata is so reliable that it is used as proxy data to uncover CO2 concentrations 20 to 40 million years ago. Okay, error number 3. Increasing CO2 drives higher temperatures. Don't worry, I won't say it doesn't. However, what Joe puts forward here is that the temperature increase would be so huge that plants would lose so much water. So bear with me for a second. So Joe, meet Henry. Henry's law is a chemistry and physics law that states how much gas is dissolved in a liquid. And this study calculates the solubility of CO2 in seawater. And you can clearly see that as temperatures increase, the sea holds less CO2, giving it off to the atmosphere. So by now you're probably familiar with this graph. It shows temperature and CO2 concentration throughout the last 800,000 years. But take a closer look. As temperature increases, CO2 follows. And that tiny little gap is on average 800 years. So climate sensitivity is a way to express the temperature increase by doubling CO2. And this is the range that the United Nations IPCC uses, 1.5 degrees to 4.5 degrees. However, the latest studies are way below that. And the most likely range in increase of temperature by doubling CO2 is between 0.4 degree to 0.6 degree.
And while many have pointed out that more evaporation should lead to more rain, climate models actually suggest that that rain comes in the form of high-energy storms, which we're already starting to see. And that massive burst of water doesn't get a chance to soak into the soil and in fact can remove a layer of topsoil with the runoff. Without extra fertilizer, plants exposed to more CO2 might grow a little bit faster at first, but they quickly hit a nitrogen plateau and stop growing as the soil gets depleted of nutrients. Plus, extra CO2 in some plants can cause chemical imbalances that causes them to lose their natural defenses against insects. So if you have plants in a controlled greenhouse environment where you can control the amount of CO2 and the amount of water and the amount of nutrients, yeah, extra CO2 could help. But in the outside world where you can't control all those variables, it would have little to no effect on the plant growth and can actually be harmful.
Oh boy, let's go. More evaporation leads to more rain, that leads to more hurricanes. And assume Joe was talking about hurricanes because he showed a video of hurricanes. Otherwise, he would just be fear-mongering and alarming people. This is the global tropical cyclone frequency. And you can see that since 1970, there's no trend at all. If any, there's a decrease in tropical storms. However, the accumulated cyclone energy has increased since 1970. And the crucial word here is since, because before that, we didn't have a measurement for that. But we do know that cyclones and hurricanes are influenced by the Pacific Decadal Oscillation, the Atlantic MULTI-DECADAL Oscillation, and the El Niños and La Niñas, which in turn, all of them are influenced by the sun's output on Earth. So I downloaded the data and plotted this graph, and you can see that the accumulated energy has a slight increased trend. So to make it easier to visualize, I created a 12-month running average. And now we can plot it against the Pacific Decadal Oscillation, and we can see that it correlates quite well, except for the green box. And the reason for that is that at that time, the Atlantic was very cold. And these ups and downs in ocean temperature are cycles that last 62 to 66 years and always existed and will always exist. This one is not much of an error, but Joe was very dismissive about it. He said plants will stop growing when they hit a nitrogen plateau. But plants will stop growing when they hit a nitrogen plateau at any CO2 concentration. The problem is that Joe read an article about another article about the actual study. And the actual study starts with a factual statement. The stimulation of plant growth by elevated CO2 concentration has been widely observed, period. And then it continues. Elevated CO2 stimulated plants' biomass half as much under ambient nitrogen as under enriched nitrogen supply. So let's get some definitions first. Plants under CO2 enrichment will grow between 18% and 40% more comparing to current CO2 levels. And this number comes from 4 major studies in the Wyoming, Oak Ridge, Duke University, and Kennedy Space Center. So going back to the study that Joe mentioned, what they found is that after the 3rd year, plants will grow more if they receive more nitrogen. That's all. These 2 errors will have to be analyzed together. So this study analyzed 8 other studies on the effects of elevated CO2 on the insect-plant interactions. And they covered a total 22 plant species. And what they found is that by having bigger plants, insects will eat more. And they state, one of the outcomes of the increased feeding rate is that insects will also ingest more defensive compounds. Elevated CO2 will allow plants to allocate more carbohydrate resources, generating higher concentrations of defensive compounds active against insects. And another important study comes from China, and they state, The feeding pattern, growth, and development of cheering herbivores were all influenced by elevated CO2, who increased feeding intensity and time for enough nitrogen nutrition, which in turn made them more subjected to their natural enemies and decreased their growth, breeding, and survival rates. And why is this study important? Because it not only analyzed CO2, but it analyzed the plants, the insects, and their predators, covering the whole spectrum of a plant environment. And this environment depends on the nitrogen cycle, which, waiting only for the decay of leaves in the ground to put back the nitrogen in the soil, is very slow, and the insects make it a lot faster through digestion. And by doing so, they speed up the process and increase total plant abundance in 18%. So, no, Joe, it's the complete opposite of what you said. Plants will only benefit from elevated CO2 in the outside world. Subscribe and watch this video on how the climate change scare started. Thank you and see you next time.